Hi everyone, welcome to the first Solidworks CSWA certification. Just 1 second, sorry guys. Sorry about that guys. Um, yeah, so the way today's going to work is that we're going to have Trevor and Luca go over some parts and assemblies to help you guys prepare for the CSWA exam. Trevor will be going over parts. Luca will be going over assemblies. We're going to start off with a general 10 minutes question period about the exam and parts and stuff in SolidWorks questions, after which we will be going to start with Luca on assemblies. We will take a bit of a 10-minute break / intermission period where you guys will have an opportunity to ask other general SolidWorks questions that might have popped up, and then we'll move on to Trevor. While Trevor and Luca are doing their sections, you guys are free to use the YouTube chat to be able to communicate any questions, and I will interrupt either of them and let them know of your questions, and we will get it sorted out that way. So we are aiming for about 2 hours, based on how long or if there's any complications and questions. We are looking at maybe 3 hours max. Does that make sense? Okay. So if you just give me 1 second. Okay. We are 1 second. Okay, so with this, we're going to start our first 10-ish minutes question period. The first question from Mohammed already. Is the exam purely multiple choice? Are we writing answers as well?
First of all, hey everyone, pleasure to be here. uh, it is, I believe it's multiple choice. I took it 2 years ago, so it may have changed, but from what I remember, it was multiple choice, and I think there was a 10% room for error between what you get as your number, your final number, and what the numbers on the multiple choice may be. So keep that in mind, but yeah, I'm pretty sure it's multiple choice.
So I will add on to that. It's a bit of both. It's more multiple choice than anything. They will give you options or they'll ask you to enter in, for example, the mass on your part, and the allowable error is 1% from what you get on SolidWorks and what they show you on the exam.
Thank you for correcting that.
Yeah.
10% is a lot, actually.
The next question is about, will the video be available asynchronous? Yeah, so this is a live stream. We'll be keeping it up on our YouTube afterwards. So if you have to leave at any time or anything like that, you're more than free to come back and watch it that way if that's what you prefer.
Love it. Every time I bungle the assembly, that's going to be recorded forever.
It's part of the process.
Now. Okay. We'll wait another couple of minutes to see if there's any other general questions about SolidWorks tools, if you want us to show you anything specifically, or questions about the CSWA exam or anything like that. And if not, then we'll get started within the next 2 to 3 minutes.
Yeah, thinking back, I do remember having to fill in some numbers too.
Yeah, they make you either enter in the mass or choose the mass that matches as closely with what you've got, or the center of gravity, or center of mass, sorry, whichever it is.
Big econ exam vibes where the intervals are so small and so close together that you're like, Christ, I hope I didn't enter something wrong in my calculator or round it wrong.
Yeah. Okay. So it doesn't seem to be any real pressing questions. We'll probably just get started then.
Sounds good.
All right. Let me know when you can. Let me know when you can see it.
Yep, it's there.
Perfect. Okay. Are we live?
Yeah. So there's a quick question just before we get started. The question is, will you guys be able to do any requested modeling questions? Yes and no. We can either do that really quickly right now, since we were kind of in the middle of that 10-minute period before we do the stuff we wanted to do. That's up to you guys, Luca and Trevor. Or you can wait for Luca to finish his part, and then we can do that in the middle 10-minute period.
It doesn't really matter to me if they have anything specific now. I guess we can just address it right away.
Yeah, so
I agree with
Shrifty,
that.
if you have a specific model in mind or a specific question about modeling, we'll be free to answer that question right now.
I'm thinking if it's making the entire model, it would take some time. If it's good, maybe we'll switch to it for the part that I'm making, but we'll see. Or we can just explain the process of doing it. Because usually you can look at something and be like, you kind of figure it out in your head, like I'm gonna do this first, then this, and this, and this. So depending on the complexity of it, we'll see how it goes.
I don't have the live stream up, so you guys are gonna have to repeat any questions for my benefit.
Yeah, just give me 1 second.
Or just drop them in the Zoom chat.
Yeah. So, okay, so there's 2 questions about and they just want a procedure for this one. On the 2018 CSWA practice exam, the very first model, let me pull that up for you guys, or if one of you two wants to pull that up.
I'll do a Google search. I feel like on the practice exam. Okay.
The first model question.
Oh, I think I found something. Screen 2. Sorry, should I just slide this over? This one?
Is this the question you're asking about? Is this the model you're asking about, Shrifty?
I said first.
Yes, that's the one.
Yes. Okay, cool.
So just a general procedure on how you would go about doing it.
Okay. I could probably do this one. So usually, or with these CSWA exams, the models that they give you, everything you need is there. Nothing will be missing. You might have to infer some things, but every dimension you'll need is there. So with this one, I've done this a few times actually for other reasons. But as long as you input everything that's there, you'll be fine. You have to remember the tangent here. That's a big one. And put in the dimensions they give you. So you can see this is 45 degrees. This is 5 something. Except for this one. Yeah. So 5 millimeters. Yeah, that makes sense. Not inches. 5 millimeters. You can also infer that this is 5 millimeters if you want to do the math and just looking at it, but don't put in 5 millimeters. Put in the 45 degrees. It makes sense now, but for other things, like when you have a global variable and you have it set to 5 up here and 5 across here, it will likely mess something up. So to actually draw this thing, I would just sketch it all out first, like the whole outline, something along those lines of what it looks like, and then you add in your dimensions afterwards. Do you guys think we should start it very quickly?
I don't know if that's totally necessary, but I will add what might cause some confusion with this part is there's the 2 tangent signs on the drawing. And what that means is that there's 2 tangent arcs right next to each other. As soon as one tangent arc starts, a second one. As soon as one tangent arc ends, the second one starts. I don't know if Trevor, you want to quickly do a demo of that.
Yeah, I'm trying to. There we go. So I'll just do it very quickly. I'm not going to go through the whole process of saving and all that stuff at the beginning. But where are you? There we go. Oh, my thing's cut in half. There we go. Let's do it on the front plane. It's sideways, but that's okay. So I'll just draw this bottom part here. I'm pointing at the screen, but you can see just this bottom part here. So below the circle. Again, this is very rough, so I'm not in the origin or anything like that. But we'll do that. And then you want a tangent there, the other way. And then you want another tangent off that point. Something like that. And when you hover over the point at the end, so right now it's a straight line. I'm sure you went over this in the lecture. But when you hover over it, it will give you a tangent and it automatically adds the relation. So that's the useful feature. If not, you can draw in your line. I'll just draw a arc here. Let's call it a 3-point arc, not a tangent one. So it's 1, 2, and 3, somewhere here. You can add the relation of tangent afterwards. So I'm holding control, clicking both lines, and then making them tangent. And then you would have to put in all the dimensions afterwards. So I'll do a couple quickly. There's a small thing there, and then this one goes all the way up. And one thing is the center of the circle. Again, nothing's on the origin, so it's kind of messy, but I'm just going to fix something for now. That doesn't also help. But you can see that the center of this circle, well, where it says radius of 29, the center of that is 19 millimeters up from this bottom face. So you have to make that in place. And then the other constraint for where the center is on the line. So if you have it 19 millimeters high, it might be, why is this not going? Well, again, that's not right, but it might be up here. But come on, there we go. So you might have it up here. Yeah, I know, it's passing up. It might be up here, but you really want it on the line. So that's where it should be, even if it's like close. Like I think that automatically snapped to it, but you know what I mean? If it's not exactly on the line, that'll mess something up. And after you put in each dimension once, you can, if you have it printed, you can cross it off or just make a note of the fact that it's done and then go to the next one. Just so you kind of know what you did. And at the very end, after you drew the whole thing, just recheck each dimension again, and you should be good. One other thing too. Oh, sorry, go ahead.
Yeah, if you finish up and you use the measure tool, if you've got the time, then you can know for sure that you got everything right, because the measure tool will confirm the same dimensions that are on the drawing.
And the thing I was going to say is that when you're doing your dimensions, place the dimension where it's shown on the drawing, so you can easily refer back to it. So for example, this 45 degrees between this line and that line, let's make it 45. That is basically where it is. It's not down here. It's not way up in space on the other end like that. You want to have it in the same spot so you know where it is. And the same thing for the 7. Sorry, this 7 here. You want to place it exactly where it is on the drawing so you know it's right. Just like that. It's not going to be up here. It's not over in this side over here. It's exactly where it is on the drawing. So yeah, that's another good tip for actually any code, but this one especially, because there's a lot of dimensions. Okay. Do you think that's enough for this guy?
Yeah, Shrifty, if there's anything else that you wanted to ask about this model specifically, please let us know. But we'll move on to the next question, which was about the last modeling part question from this same paper. So if you scroll down, Trevor, should be the last part model here.
Oh, the last one?
Yeah. So I think they asked you to do like 3 models or 3 adjustments. Go
Oh, last part?
Yeah. Up a bit. Oh, this one then. So
okay.
How would you go about doing something like this?
So what's it asking for? Okay, start off with this cutout already. So the only thing you're adding is the shell, I think, right?
Yeah, it would be this shelling out. I don't know. Remember if that's the right technical term for it.
Yep, shell somewhere here. But yeah, so if you already have that cutout, that's I don't know what you want to call it, angled cutout, where there'd be a dowel through and something can move in there. The most important part is this. Excuse me. So let me think for a sec. So you would have this entire drawing, this entire model.
I think we can do a pretty good simulation of this by just making a block, putting a hole through the center, and then trying to shell out the block.
Okay.
It's the same thing, right?
That is true.
And it's going to be a lot simpler than recreating the whole thing.
Okay. So let's do a block. Call it 100 by 100.
Because if I'm not mistaken, the shell tool will by default put a wall around the hole in the center as well, whereas there's none here. So there's some parameter you'll have to adjust for that. Although I might be mistaken as to how it works in Solidworks.
Call this 30.
In this, okay.
And I just want to ask everyone watching the stream, is the SolidWorks smooth? Like, can you see everything well? Or is it kind of jumpy? Just put in the chat.
Your model looks like this.
Possibly do something.
It's good.
Just
it's good on the Zoom call,
so if
there's issues with
nothing else.
They're going to be introduced in the YouTube stream, which I think will be considerably harder for us to do anything about.
I'm watching the YouTube stream at the same time just to make sure, so we should be okay.
Oh, it's good?
Okay.
Yeah.
Pretty good then?
We're good.
Okay, cool. I'm just going to do something to make it a bit more
Once you do that, double click.
I know there's that,
what we will be doing
another
is
length on the
select
side.
this face, press S key.
You know what I mean? Like, you know how there's like 2 depths here, like one on the right side, and then it goes way deeper on the left.
That's
so
not. Yeah. Oh yeah, I see what you mean. That's not going to do that though. Yeah, it's analogous, I guess. Doesn't matter.
Oh, you're right, because it's the other way.
Yeah, it's not. It's the other way. It's smaller than the outline.
Okay.
Yeah, I'd You know what? You know what? No, it will do that. It will do that. Never mind. If you shell it out from the other side, like you want to
Select this
you want
face
to cut
again,
out one side of it, and then
offset
shell it out
entities
from
by
the
1
opposite
mm.
side.
Okay. I see.
Yeah, see, cut that partially.
Oh, I was just gonna make it bigger
Okay, yeah. Either way, it's analogous. It's the same thing.
and then shell this side pretty much.
Yeah. Okay, yeah. Now I see it. I wasn't quite visualizing that.
Okay,
Sorry.
so shell, where is shell?
Right next to mirror, yeah.
So you want to do that face. The parameter, is it 1? I'll do 1 in this case.
Yeah. Check the show preview.
Side.
That would
You
help.
might want to uncheck shell outward because shell
Once you
outward
do
is going to
that,
expand the size of the
Double
thing.
click,
There.
Okay.
create the cutout.
Yeah.
Yeah.
So shell outwards.
How? So
Shell.
we know
Normally it shells
this is 8 mm,
inwards. Shell
so you
outwards will
can
expand the size outwards.
create the
right?
cutout of 7 mm.
Okay.
That leaves the thickness
That's-
of 1 mm.
Yeah. So see, it's putting a shell around the hole in the center, which is what I thought it would do.
I do know a workaround for sure that would work. But do you think there's a feature in SolidWorks to not do that?
I would.
Oh, I just clicked the
Yeah,
circle.
there you go. All right, select the two faces.
So yeah, what that was is I just clicked the inside circle, so it's showing that as well. So face 1 is this outer face, and face 2 is the inside of the circle. And
So
then
the takeaway is when you use the shell tool, whichever face you choose, it's going to eliminate.
and
So
that
here-
didn't wreck the circle in the back, right? Like making it smaller.
No, it shouldn't. Well,
Yeah.
give it a measure.
True. It was 20, or it was an even number before. So
So it's always good to confirm because afterwards, because these things don't always. Yeah, 30. It's perfect.
perfect.
These tools don't always behave the way you might intuitively expect them to,
So
and it's not always easy to tell in the preview.
if I was in the exam and this happened, I didn't know you can select the other face, and it just so happened to do this. What did I do? That's not what I was going for.
So there is a comment, and I was going to bring this up as well. A key note on this question is that you still want 12 millimeters of the material from the back face still there. And when you just purely run a shell, it's going to shell out the whole material relative to the face you click on, right?
That is correct. That's actually true. Alternatively, you can create a new sketch on the face. And if you can use the sketch tool offset entities. Convert will work technically, but it won't do what you want because they're not offset.
You have to do both, right? To get the
No,
entities
but
you want on the sketch.
But if you do offset entities, you can straight out select the outer chain.
Oh, okay. Let's do that then.
It's got a tool in it for it. Yeah.
Yeah, I was going to
So you can
recommend using offset entities.
Yeah, now it's lagging when you do the big bulk selection. If you use offset, there's there you go, select chain and all that.
So what I did here was, it was originally the other way, like shelling outwards before, similar thing. I hit reverse, so it's going inwards, and everything else is there. Oh, parameter, it's a 1 millimeter there, so we'll do it here too.
Yeah. And I would just make this a cut
Yeah, so this would be a cut all the
on its
way.
own.
Extrude cut.
Yeah, and use the offset from surface, right? It's lagging behind a bit, so you might want to give it a second
Okay.
to catch
Yeah,
up.
so I'm going too fast. All right, so offset. Offset from surface. The
Yeah.
surface would be this one. And the offset is 1 millimeter, right?
Yeah. Oh no.
So that will cut everything down like a simple square. Direction 2. No, let's not do that. We'll do 2 separate cuts.
Yeah, you can do that, and then you can do a separate cut, similarly selecting the other face. Alternately, you're going to laugh at me because I just remembered this is an option. We could have just used the multi-thickness shell tool.
Oh,
That's a thing.
that works too. As you can see,
yeah.
there's too many ways to do one thing.
There's a lot of ways to skin a cat here. Well, that's kind of a distasteful expression when you think about it.
So offset millimeter. Oh, wrong way. Offset reverse 1 millimeter inwards. And then you would do the same thing. Cut it. Up to offset from surface. And let's say this is 10 millimeters here. Let's say you want to leave a space of 5 millimeters. Then that way you would just cut it only 5 millimeters, and you would have your distance. Actually, I think this might be 20.
Yeah.
Yes. So let's say you wanted 10 millimeters in the back. Your whole thing is 20, and you only cut it 10. It leaves you with 10. And if you want to see from a section view how it works.
Oh yeah, section view, best tool in the whole program.
Honestly.
Yeah, really. It's like 75% of my work right there.
So hopefully that explains it.
You want to do the demo with the multi-thickness offset? I mean, might as well make it complete since we're here
Sure.
already.
Sure. You'll have to walk me through this one because I never used it before.
Yeah, honestly, I haven't used this in a while either, so it'll be under shell.
Figure it out.
Yeah, so parameters, just select the main face, check show preview so we can actually see what the hell's going on, and the circular face too. And then multi-thickness settings, set it to a completely different, yeah. Set that to like 5 millimeters or something.
Oh, that worked. So
There
if
you
you
go.
wanted in the thing, in the model, it's 12. Wow, that was very, very easy.
Yeah, I did not expect that to actually work that easy.
So again, section view. Put this back. And if you want to check, the trusty measure tool is always there.
Yeah,
measure.
always measure after yourselves.
Where's the distance? Oh, my bad.
My least favorite thing about the measure tool, I almost never want to measure the area of faces combined. Almost never.
Yeah, I know. So DZ.
I'm not sure. No, you got the wrong 2 faces selected.
That's odd. Or maybe
No, you just went. Yeah, but it just wasn't the right faces.
Oh, okay. Perfect. So the normal distance is 12. And the DZ is 12. Delta Z. Okay, that's good to
fancy.
know. Cool. So yeah, that's that. Again, it was a multi-thickness shell tool, and you just select the face you want to cut out from the beginning, the first 2, and then the ones you want to keep, I guess, and the distance of the shell that you want to keep is the number you put in.
I gotta be honest, the shell tool is emphasized a lot, and I think it's mainly because of injection molding. You know, you make a shell out of something, then it's a part you can injection mold and all that, but I really rarely use it myself, and I think most people rarely use it.
Yeah, I don't use it very often either.
Yeah,
it's just good to know.
Outside of like plastic injection molded parts, I honestly just don't think shelled out shapes are something you do that much.
With the exam, you got to know it, so practice. Yeah. Okay, should we start the Lucas assemblies?
Yeah, we'll start with your stuff, Luca. So if you just want to get ready.
I
Oh,
will
joy.
turn my screen share off if I can find it. There we go.
All right, let me know when you can see it.
Yep, it's there.
Cool.
Should be coming up on
Oh,
the
wow,
screen.
the notification pops up right actually when you can see it. All right, so hi guys. As Daniel said, I'm Luca, and I'll be doing the assembly tonight. I realize it's afternoon for you guys. So this here mechanism is a Scotch yoke. Shout out to my dad, who's probably watching this. He favors this mechanism. It's one of a bunch of mechanisms for turning rotary motion into linear motion. The advantage being that this does it particularly smoothly on account of this being a perfect circle. If you spin this at a constant velocity, you kind of get a sinusoidal pattern of motion. So very, very smooth acceleration in the linear motion. This whole thing is held together with dowels on the bottom for the bottom plate and for the two bushings here. And everything else is sort of pressed together. Don't hesitate at any point to cut in with questions if you have questions related to the assembly or whatever. I'm going to restart this assembly from the start. So I'm going to create a new assembly, and I'm going to drop in my base part. In SolidWorks, when you drop in a base, by default, it'll be fixed in space, which is important because obviously you have all of these parts that you're assembling together, even if you assemble them perfectly to each other, so they're all fixed relative to each other. If one of them isn't fixed in space, the whole assembly is going to be floating around. I've done that in the past, and it's quite annoying. So if I drop the base in first, you'll see there's a little F next to it on the left in the part tree. That means it's fixed in space. I can drag that around like I want. It's going to say the selected component is fixed. It cannot be moved. If you'd realize that you wanted to make a different one fixed, you can actually change that. You can right click the part, hit float. Now I can drag it around as I want. And then I can insert another part and right click it and hit fix. Just make sure that you have at least one part fixed in your assembly, preferably your base part. And to hold this onto the rest, I'm going to make a dowel, or I'm going to insert a dowel. So now I have the base fixed in space and the dowel next to it, just floating around wherever it wants. I have to constrain this dowel somehow to the base. I have the list of standard mates here, all of which are fairly self-explanatory. Coincident means two faces touching each other, or two things touching each other. Parallels, parallel, perpendicular, self-explanatory. Tangent is tangent, so you can see that it'll make it tangent. It'll make a round face tangent to a flat one, and so on. I can make a distance or an angle or a concentric. There's some advanced mates which won't be useful for this particular part, but some of which are interesting, which I can demonstrate later, and the mechanical mates, which altogether won't be useful here. If you want me to demonstrate any of this, guys, you can pipe up and I can demonstrate a specific mate. In this instance, what I'm going to do is usually, actually, I very often just trust what SolidWorks picks by default. So I'm going to pick that face and that face. SolidWorks is automatically going to see they're both cylindrical and make them concentric, which is perfect for me. You'll notice the lock rotation button. That's important. In some instances, like you're simulating a mechanism, you want a concentric mate to be able to rotate. But in this instance, it's a dowel pinning two things together. And remember, I want my assembly to be defined, the fewest things moving possible. So I'm going to lock the rotation to achieve that.
Say that last part again.
You want your assembly to be defined, fewest things moving possible. So see at the bottom here, it says underdefined. That's because I can still move the thing up and down. That's a degree of freedom. A part is able to move. Ideally in an assembly, nothing moves unless you're simulating some sort of mechanism. So to stop this from moving altogether, now that I've made it concentric to the base and I've locked the rotation so it can't spin within that concentricity, I can select the bottom face of the base and the bottom face of the dowel. It's automatically going to select coincident, which is perfect. If I hit the check mark, you can see down in the bottom right, it's now fully defined, which means that neither of these parts can move. They're fully constrained. The mates that I've added prevent them from moving. There. Now, I've already done this dowel once, and this other dowel next to it, that's basically the exact same situation. There's no difference about it. So I could just repeat what I've just done, or I could use a handy tool called Copy with Mates. I had to do a lot of this for my capstone because I wanted to get a lot of fasteners in for the assembly drawing. And very often with fasteners, this is a very useful thing to do. You can copy a single part with mates, or you can select several parts and copy them as a group with their mates. So you see, if I select the part, under Insert Components, there's a little arrow, and I'm going to select Copy with Mates. It's going to say Selected Components, so I know that this is the correct component, and I'm going to hit the little next arrow at the top right of the dialog, and it's going to give me options for the mates. So right now I have the concentric one selected. I want to move that over to this other face. Bam. And the coincident one, it remains coincident with the same face. So I'm just going to check the repeat box. Now, component's been placed. I can see it's in the right position. I just have to click OK. And I'm done. I can cancel out of the dialog now. Now I have my two dowels copied over with mates. Everything good so far, guys? Anything unclear? Give you a second in the chat to type if you have any questions or any concerns, anything that needs clarifying. Also, is my head in frame because I can't see myself?
Yeah, you're good. No questions on the chat yet.
Awesome, great. So no questions on the chat. I'm going to add the back plate, which attaches to this with two dowels. So you can see on the bottom, there's a couple dowel holes. Yep.
You know how when you hit Insert Components and it shows you like your whole list of components on the side?
Oh yeah, good point. Yeah.
How you get those there versus having to search through like files and stuff?
That's a good point. Yes. So before starting all this, what I did was I created the assembly. I created all the parts and I created the assembly, and I have them all open. So by default, if you have something open, you see all of these, they're open in SolidWorks. When you hit Insert Components, it's going to show up in the list of open documents. However, if the document wasn't open, you can hit Browse, and that will allow you to select any file in your file system to add to the thing. It just occurred to me, not that it really matters, but it's in the downloads folder because I'm too lazy to create random things outside the downloads folder. I didn't actually download these, I made it myself. So yeah, if your component's not open, you're going to have to browse to find it. I suggest opening your components first because it's just easier. They show up right in the list and you don't have to look for them, and you know that it's the right thing because you've already opened it and have a look at it. So when you're assembling, I suggest opening something, then adding it to the assembly. You can always close the SolidWorks window for that thing. So I can close the backplate window here, and if I do that, it's actually not going to get rid of the backplate. There. See, the backplate window just disappears. SolidWorks refocuses to another window, but if I go back to my assembly, it hasn't removed the backplate. It's still open by virtue of now being in the assembly. Parts remain open for so long as they're either open in their own files or in an assembly.
Okay.
All right.
And don't forget to save at the beginning too. I remember in the tutorials they pushed that when I was doing it. Like save it first, you can always Control S really quickly.
Yeah.
Like every 5 minutes.
Save your assembly. Although I'm kind of a hypocrite saying that, because very often I save my assembly when I get the half-hour you haven't saved notification. All right, so I'm going to save that as assembly too, next to the original assembly. So now I'm going to mate this back plate. I'm going to take the bottom face of the back plate. It's very handy whenever you select a face of a part, it goes transparent, which allows you to select things behind it quite easily, like so. There. So I select those two, it correctly selects coincident. Good. Now, I'm going to select that and that, and I'm going to make it concentric. And I'm not going to lock rotation here because remember that pin is already unable to rotate. If I locked rotation, what it would do is it would prevent this motion. But I'm going to prevent that motion regardless by also constraining this pin here to be concentric. So you see, I'm back to fully defined. So when you do things like lock rotation, you have to think of the actual physical implications. That pin is already unable to rotate. So if I prevent the back plate from rotating relative to that pin, I can lock it at any arbitrary angle. But more accurately, what I want to do is I want to constrain the back plate concentric to both dowels, which will prevent it from rotating anyways. When you add mates, SolidWorks actually just recalculates the possible motion of the parts, and it can see that none of these are able to move. All right. And it doesn't necessarily make sense in this context, but I'm going to do it anyways as a demonstration. I'm going to leave these in a sub-assembly. So I'm going to go File, make Assembly from Assembly, and I'm going to create another assembly that contains this one. It's probably not something you're going to want to do on the test, unless there's a lot of repeated parts. So in fact, next to that, I just came up with a better idea. When there's a lot of repeated parts, it's easier to do that sometimes. So I can do this. I'm gonna blitz through this here without really commenting on it. Bear with me because it's for the purpose of a demonstration.
So there is a question about mating in the chat. What's the difference between
for sure.
concentric and coincident mates?
So a coincident mate will mate, for instance, two faces or two lines or some such to be on top of each other. Whereas a concentric mate will mate two round objects. So see, I selected the two cylinders there. And while technically they are coincident actually isn't even an option here. What I'm really doing is I'm making them concentric. So concentric makes two round things have a common central axis, whereas coincident makes two faces touch each other, usually flat ones. In fact, coincident will not even function on round faces. So
just to add on a little bit, if you were to put that small dowel inside the bigger hole on the top and use a concentric mate, like Lucas said, the central axis.
The central axis would be common. It would, and I'll just do that as a demo. It would literally float in the middle of it. So see, if I select this and this, it actually just floats in the middle. As opposed to, I can also make it tangent where it will just touch. Although that can have unpredictable effects, as you just saw right there. So I'm going to, as I said, I'm deliberately skipping explaining this bit because I'm going to come back to it. This is to demonstrate two different possible options for assembling something like this. So as you can see, I have a bushing with its dowels assembled on here. One of two, if you recall from the original assembly. One of two. Those are identical. Same bushings, same dowels. So what I can do here, the kind of obvious solution is I'm just going to drop the bushing and the dowels in the assembly like I did. And then, as you recall from a few minutes ago, I can select them and I could go insert components and copy with mates. That will copy the whole set. And I can change the concentric mates, right, to be on the other side instead. And then the coincident mate repeats. I can check. And that does correctly position it. But as you get into bigger assemblies with things that repeat that have a lot of parts, it's not really feasible for you to select, let's say, 60 repeating parts and just, copy them over. That's a little bit ridiculous. Think like a snake robot that has 6 links, 5 of which or 4 of which are identical, and each link has 15 parts. It just doesn't make any sense to put the link into the main assembly and then select all of it and copy with mates a bunch of times. Copy with mates, by the way, gets slow. It's a slow process, and it gets slower the more you do it because you're adding a lot of mates to your main assembly. What I can instead do, getting rid of all of this for a moment, dowel, dowel, bushing, bushing, dowel, dowel, delete. Getting rid of all of that, what I can instead do is a bit more of a logical approach. So those parts form a logical group, and there's several instances of that group. So what I'm going to do is I'm going to create a new assembly and watch the units in your assemblies. They might default to inches, even though your parts are in millimeter for instance, and it might not matter, but some things you do in assemblies, the units will matter, like adding sketches in the assembly and such. So here, and as the base of this new assembly, I'm going to add the bushing, and I'm going to insert a dowel, and I'm going to mate that dowel to the bushing as I did just a minute ago, but this time in its own subassembly. So that face and that face are going to be coincident, and the 2 round faces are going to be concentric with rotation locked. And copy with mates. I'm going to select the dowel as my component. I'm going to repeat the coincident. I could change the coincident mate for this, by the way, to the bottom face of the other hole, but those 2 faces are coplanar. They're on the exact same plane, so there's no point in changing the coincident mate because you see the end of the dowel is coincident with the face of one hole when it's coincident with the face of the other hole. They exist along the same plane. Whoops. If you hit the check mark too many times in that dialog, you're going to accidentally add one like this. So I'm going to hit the section tool up at the top here, and I'm going to drop a section to show what I mean. See, this face and this face are along the same plane. So if I constrain the end of the dowel to be coincident to that face, it's not bounded by the extents of the face. It'll be coincident with the plane of that flat face anywhere in space. Say in the chat if that doesn't make sense to you guys, so I can kind of clarify it. So now
I'm kind of confused, to be honest.
Oh, okay. So here, I'll do a better drop the section. So you see, I have this dowel. The mates are concentric. So you see the outer face of the dowel is concentric with the outer face of the hole, or the inner face of the hole here. And coincident, the end face of the dowel is coincident with the end face of the hole. So if I create another copy of this dowel, it'll be more obvious. It'll make more sense to do it this way than the copy with mates tool. It got copied, it got pasted outside the section. There we go. So see, now if I have a second dowel, intuitively, if I make it concentric there, intuitively you would say, okay, do the same thing as the previous dowel, the bottom face of this hole, the end of the dowel, right? And that's correct. But I'm just saying that I can achieve the same effect by selecting this face, the bottom face of the other hole.
Oh, okay.
And the end of the dowel. Because the bottom faces of these 2 holes are coplanar, right? They're along the same plane. And because the coincident tool doesn't actually attach a face to a face, it attaches the plane of a face to the plane of a face, and the planes go on forever, flat, that achieves the same effect. And the reason that matters is that when I use the copy with mates tool, Very often it's going to be for something like this, where it's going to be a whole bunch of fasteners on one face, or a whole bunch of fasteners on parallel coplanar faces. So in this instance, I don't need to change the coincident to the other face. I can just repeat it. I only need to change the concentric. Does that make sense?
To me, yeah, because you're using like the bottom face twice, basically.
Yeah.
Like the bottom hole twice.
So the bottom, the point is that in a coincident mate, it's for, you know, two flat faces coincident. If two faces exist along the same plane, they are functionally the same to the coincident mate. It just takes the infinite plane of a flat face, or the infinite plane coplanar with a flat face.
Okay.
I'd encourage you guys to play around with it a lot in the software. So again, cut in if that didn't make sense in the chat. Cool. Again, don't hesitate with the questions, guys. So you see now I have in the bottom right this fully defined little subassembly. I'm going to save it as bushing subassembly. Now, if I go back into my main assembly and I insert the bushing subassembly, this makes a whole lot more sense. First of all, because I can easily constrain this bushing subassembly in the right spot. So there you go, coincident. This probably won't matter on the test, but it could if you end up having a really repetitive, like a few components that are repeated a lot. So there. And then what I can do is I can select the whole bushing subassembly and I can copy with mates it over. In instances with a lot of parts in the same subassembly, this actually makes things a lot simpler. In this instance, it's about functionally the same in terms of complication. However, critically, what it does is SolidWorks doesn't need to calculate all the mates in the subassemblies. The subassemblies calculate their mates once and they're saved. And usually, unless you deliberately right-click it and use the make flexible option, things won't move and all that, which actually makes things run a lot faster on your computer. So if you can confine things to subassemblies, it can speed up work with assemblies quite a bit. All right, I'm going to insert another component. This time I'm going to insert the rotating plate. So now we're starting with things that move. So I'm going to insert the pin. And I'm going to mate this pin correctly to the rotating plate. So that pin goes into the center of the plate, like so. And I'm going to check lock rotation because that pin, picture it as being pressed into the plate. I don't want it to move relative to the rotating plate. Now I'll put the rotating plate backing onto that face, and I can constrain the other side of the pin to the central hole in the back plate. Now I'm not going to check lock rotation because I want that to be able to move as a motion demonstration. I can lock it later on to render the whole subassembly fixed. So you see it says underdefined, and that's correct. I can, in fact, spin the thing around. Another pin. Now you see that pin is, it just adds that coincident mate there, which is technically correct, right? The two faces are coincident, but they're not in the direction I want. I want the pin flipped around the other way. That's quite common. When that happens, you want to look at mate alignment down here at the bottom of the dialog and hit anti-aligned to flip it around. And then I'm going to constrain these two faces concentric with rotation locked, pressed together. Remember, guys, do not hesitate to interrupt me at any point. So I'm going to insert this cam slider here, this cam channel. And I'm going to insert the sliders on either side. So I'm gonna go back to the finished assembly so you guys can see again what we're working towards. Yeah, I'll drag it around for rotation real slow. So to do that, I'm going to assemble this slider here onto that face and that face onto that face with rotation locked. These are a lot of concentric mates. I'm going to demonstrate some other mates at the end, just as pure demos, because this assembly admittedly doesn't have a whole lot of variety. Coincident here. And concentric there. And flip the coincident around. There we go. So you see it has it going the wrong way. I can click the button there to reverse that new coincident mate and get it on the right side. Now, one thing here is I might be tempted in this case to mate this face to this one coincident. Very functional selection process. Thank you, Solidworks. So you see coincident, but that would be a mistake because if I do that, I will see that see, it doesn't quite align with the center hole there. Get this out of the way. That's because there's actually supposed to be a gap between those two faces. So in this instance, I can go back and the mate's at the bottom and I can edit that mate by right-clicking it and clicking edit feature. I'll make it parallel instead. And I'm going to finish this up by mating that to that concentric. And there's no need to lock the rotation in this instance because the parallel mate more or less takes care of that for us. So now it's sliding back and forth. And I have one last mate to complete this here. This slider here has to be inside, or this pin here has to be inside this cam channel. So I can select the outer edge of the pin and one face of the cam there. And it's going to make them tangent, which is correct. But as you can see, the alignment is wrong. So I'm going to flip the mate alignment again there and hit check. So now you can see we have the finished assembly. Works as intended. And if I go back to the mate that, gotta find it first. Another way you can find mates that are being troublesome is you can select the part that they affect. There we go. Expand that part, and under that part, there's going to be a mates in assembly XYZ. So I have this concentric mate with the back plate that is allowing this whole thing to rotate because the rotation is not locked. If I right click it and hit lock rotation, you can see in the bottom right, my assembly is now fully defined and no longer able to move.
So that part there is just like a check, right? Because that's the only thing you want to move. And if that is locked and it's still underdefined, then you have some other problem, right?
Exactly. Yeah. So if I'd locked that rotation and it was still underdefined, it means I have other parts able to move, which is a problem. I don't want that. So are there any specific questions? Otherwise, I'm going to demo a couple of other just random mates.
There aren't any questions right now specifically about the assembly.
Okay. So one mate I think is important is, and I got another bushing in here. One of the advanced mates called a width mate. That one might come in handy on the test. So I'm not going to have an assembly here, obviously, that's going to use all the SolidWorks mates because it would have to be large or convoluted or some such. But this one, in my opinion, is particularly important. So
There's
under
a
standard
question.
mates, under advanced mates.
Sorry.
Okay, I'll just finish the width thing
Sure.
quick and then we can go to the question. Under advanced mates, there's a width mate. You select that, it's going to ask you to select a width and tab. What this does is it allows you to center one part within the other. So I'm going to select my width, which is 2 faces right there. And then when I select my tab, 2 other parallel faces here, it's going to move the tab part to be in the center of the width part, or vice versa. If I selected the tab as the width and the width as the tab, it would actually have the same effect. So you see this extra bushing here is now centered exactly between those 2 faces by its 2 faces, which is very useful for sometimes having like rectangular sliders or something like that. And you can see it's free to move like that. Keep that one in your back pocket. It comes in useful in a surprising amount of situations. So what's the question?
Yeah. So the question is, how do you lock rotation of parts?
So you lock rotation of parts either when you are creating the concentric mate. There's a, I can't really demo it here because it's already, oh no, there we go. There's a, when you're creating a concentric mate there, you can check the box under concentric to either lock or not lock the rotation. Or after the fact, you can find the mate in particular that you want to affect there. So either in the tree of mates for the whole assembly, or again, select the part, expand the part, and underneath look at the mates that affect the part. And you can right click the mate and click lock rotation, which will lock it, you know, no longer moves. And then you can right click and click unlock rotation, which allows it to move again. Make sense?
So the 2 ways are when you're making it already, it's right below the concentric mate, and then you can actually click on the concentric mate itself and then change it there, right?
Yeah.
Like those
you can
are the 2
actually
main
right
ways.
click the mate itself in the tree and change it there. If you go back and edit the mate, it'll also give you the option to check and uncheck the lock rotation box. But the fastest way is to find a mate you've already done in the tree, right click it, and click lock rotation to lock it. They've added a shortcut there because it's a fairly common operation.
There's one thing I found useful too. I think when you right click on a part in the actual, like the actual model, you can hit view mates in assembly. And I think that's the same thing as going on the part on the feature tree and viewing the mates in assembly, but it's the paperclip with at the top with the very top right, the one to the left.
There you go. Yeah, view mates, and it'll list them.
Yeah, and then you can kind of hover over it and it'll highlight what they are. So if there's
Nice.
a problem, that's another way of finding it. That I think it's the 2 parts there, like, or no, what is it?
It's
there's
the 2 pins.
There's a dividing line in the middle. Oh, so the top,
just
the
different
top part,
parts.
yes, that's it. It's like the
Yeah, I'm not
relation
sure
between
why.
part A and B is the top 3, and then the relation between part A and C is the bottom 3. And if there's another part involved with the one you clicked, there'd be another line and everything below that, right?
Yeah, it actually has several parts involved. I'm not completely sure what kind of weird algorithm they used to decide where to put that line, because you'll notice technically I have that part there and then the pin there. So the pin, the cam track.
Okay, but yeah, I've always used that one. It's fairly easy to find what's mated.
Yeah, it's good to know. See, I actually never knew that. There's so many little hidden menus in this software. So
right.
do you guys have any other questions? Anything unclear? Anything else you want me to demo? Things like that? any of the mates who are interested in clarifications about assemblies? Yep.
Okay.
You'll notice also on the left here, actually, as a side note, parts that are able to move have a little minus next to them in the tree. So that's a good way of telling if you're underdefined, you know, what the heck is making you underdefined. All the parts with the minus on the left in the tree, those are the ones that are able to move.
I did not know that. And that's very good to know.
See, I told you so many just random little things in this software. I think that the only people privileged to actually understand all this are the ones that did all the tutorials. So if I go ahead and lock that rotation, you see all the minuses disappear. Bam.
That's so cool.
Okay, doesn't look
I
like there's
think
any
there's
questions.
there's probably an animate degrees of freedom option too, but I genuinely have no clue where it is.
Yeah, it
All
doesn't
right.
look like there's any questions about the assemblies.
Okay. This footage will be made available after the fact, right? So anybody, if anything was unclear, you're free to rewatch at your leisure.
Okay. I'm
Awesome. Okay.
So just in a minute or two, we'll do like a generals question period for any random not any random question, any questions you have about the CSW exam, any tools and Solidworks you want us to demonstrate or to show, or if there's a particular problem you're running into, you can let us know about those, and we'll address those problems now. And we'll do that for about the next 10 minutes, unless no one really has any questions, and then we'll get started with the parts tutorial with Trevor.
Awesome.
Right. So there is a question regarding where someone can find more materials besides what has been given by, let's say, the professor and the actual lectures for the class.
Okay. I found a pretty good resource. I will do a quick Google search to see how you can get it again. But just give me 1 sec.
The whole CSWA test is, you know, relatively common too, right? Like it's a known thing. So there's a lot of stuff online if you root around for it.
Yeah, not to butt in, but I would definitely recommend just Googling whatever you can. There's a lot of YouTube tutorials that from years and years past that might have slightly different examples. The overall techniques might be fairly similar, but you'll get different shapes, different sizes of stuff that will be of great help in learning how to tackle different situations.
And if YouTube disappeared tomorrow, universities and centers of education around the world would just go down in flames.
Where is it? What I found was it was from Javelin Tech that I know they distributed the package. So you enter your email and then you can download it after that. But I'm just trying to find the link to get to there.
And in the meantime, if there's any other questions, feel free to put them in the chat and we'll answer those questions as well.
The Javelin Tech website is slow, or it's just my internet access.
Oh, I think I found it. So I need to get my information and then I can show you.
Yeah,
So
here. Oh yeah, I
Is
see.
it,
Never mind.
is it called CSWA Practice Exam Download Package for students?
For students and educators, yeah, that's the one.
Yeah. Let's see. I can share my screen and show you here. Is it sharing?
Yeah.
Okay, so Javelin Tech, SolidWorks, CSWA training PDF, that's what I searched. And the first one is the right one. So CSWA Practice Exam Download Package for students and educators, I think it says. But yeah, so you go down, I think still there. Cool. Yeah, you enter information and I think it downloads either right away or it sends you a link to download in your email. I don't remember, but they have very good models to practice on and all that. So I'd recommend this one, among other things. I'm not sure what else there is. There's like Lucas said, tons.
Yeah, like if you look up CSWA practice, there's a load of YouTube videos. The University of Alberta has a PDF on their website for like a SolidWorks 2010 practice. But honestly, it should transfer over. SolidWorks hasn't changed that much.
Yeah, there's the Alberta one. And quite honestly, if you're practicing, and it's kind of just a study tip, if you see something, like let's say you have 5 parts and you look at the first 3 and you're like, I could probably do those 3 very easily and they're similar, maybe just do one. Don't waste your time on doing the other 3. Do something challenging, like pick a hard one. Yeah, pick something hard. You want to do something hard and then you'll get stuck and then you'll figure out how to not get stuck and move on. And then now you know how to get past that problem. What's this one? The beginning has all like installation instructions and stuff, but don't worry about that. Yeah, actually, here's that part from
this. This is the same document. I'm pretty sure, actually.
Oh, yeah, it is.
This is the exact same document.
Okay. So actually, here's a good one. Luke, remember how you did the subassembly?
Yeah, that's what I was thinking of actually when I said that. It's like, see, the 2 middle links are identical. So say if you had one of these that was 60 links long, it'd make a lot of sense for you to, you know, instead of adding the parts 60 times or copy with made 60 times, stick them in a subassembly and move the subassembly 60 times.
Actually, all 4 of these look the same.
To be honest, you know, maybe a lazy solution, but if I had to do this 60 long, they all 4 look the same, but they're not the same sub-assembly, right?
Yes, sorry.
You could get 3 of them into a sub-assembly, like a blue pin in the back of a yellow thing would make a sub-assembly. There's 3 sets of that. If I had to do one of these 60 long, I'd probably do one of them 10 long. Like I do one in a sub-assembly, assemble 10 of them together, and then make that a sub-assembly and copy it 6 times.
I like the way you think.
Yeah, just you know, like, why bother expending the effort? You gotta think in CAD sometimes. You know, what helps you keep your document clean, and also what helps you expend less effort, because you know it's quite a bit of effort to start with.
Definitely.
Sorry, go ahead.
Sorry, I was just gonna say, before you start a part 2, just try and break down how you're gonna do it beforehand. I'll explain that when I start modeling. But what was the question?
Yeah, so there was a question about the exam itself, in that how long should the 3 parts take to make? So if I'm not mistaken, on the exam, you are given 3 parts and you have to make adjustments to them after you've made it the first time. So in general, how long would you say you should spend on that section of the exam where you have to make 3 parts and make adjustments to those 3 parts?
Like make a part and then make 3 adjustments to it, like that type of thing, like this guy here?
I'd honestly say that's going to depend on the person, but it's probably something you can only answer by doing some practice and seeing how long it takes you to do each thing.
Yeah, so If I'm not mistaken, you have to make 3 different parts, and then you have to
Yeah.
make X number of adjustments to each part. So all in all,
Okay.
how long would you say that should take someone, or what should you aim for?
Um, if you have 3 parts and your test is 2 hours, divide that by 3, and
Yeah,
then
but
you
then
know
you got
you
to do the
have to be within there.
modifications, right?
Yeah, but that's the
Yeah.
part, right? There's the assembly section, there's the multiple choice drafting section as well. So,
Yeah,
Yeah.
you really got to practice.
Yeah. I don't have an answer for how long you should take. What I can say is do the math of how long each question should take, and if it's, let's say,
Okay.
an hour and you have 3 different things to do, um, that this initial thing will probably take you much longer than whatever they make you do afterwards. So this shouldn't, let's say 20 minutes for this part. I'm just picking numbers out of the air, but kind of using it for reference. 20 minutes to make this sketch and extrude it once. So you have the solid part. And then half the amount of time, so 10 minutes to do this next thing because it's not as much work. And then another 10 minutes to be fair for each part after. But yeah, I don't know. I can't really give you an exact amount of time for each part.
Up to a point, I believe the marks breakdown is available on the Solidworks website. I can't remember how granular it is, but there is a breakdown available. So in theory, you can take the full length of the test, divide by the total marks, and then multiply by the marks of each section. So proportionally, how much of the test they expect each section to account for, right? So if there's 2 sections, one is worth 10 points and one is worth 50, logically they'd expect you to take about 5 times the time on the 50-point section. That would at least give you a start on how much you should spend on each question. It's not definitive, obviously, but it'd give you a, kind of an indication.
I will kind of add on to this. You want to spend the bulk of your time on the parts slash modeling section and the assemblies section. Um, Assemblies can be really finicky based on how they expect everything to be and where your um, coordinate system of reference might have to be located and what you have to analyze in that sense. And then parts are just going to take time to make sure you got it done the right way to make sure you got the right mass that they expect out of you. And your drafting parts shouldn't take you more than a half hour at worst, from what I've heard.
Yeah, honestly, it's like any test. You probably should do things, you know, easy stuff. You can go fast. Like, don't slow yourself down if something's easy. Don't like second guess yourself at every step. Just plow through it and check it all at the end. So like that sketch, do the entire sketch, extrude it, and then at the end, if you want, take some measurements to check that you did everything right. And that'll give you a bit of leeway when you run into something that gives you trouble. If you've gone through things relatively quickly, like don't make mistakes. But if you practice a few times, you'll be more confident. You won't second guess yourself so much. It'll allow you to go through all the stuff you're good at relatively quickly. So if you hit a snag, you get more time to kind of untangle it. If that makes any sense at all.
Oh, it does. I'm just curious if you can go back on questions. I don't remember. So if you do something quickly, like let's say you're doing the first part and then you have to do the second part. If you do the first one and you start the second one, can you go back and change your answer for the first one?
I think you can. It would have definitely been discussed in the lectures with the professor.
Okay.
Or you will be told, yeah. So the professor says you can go back. Someone mentioned in the chat, so the professor said you can go back, so it should be possible. And as long as you do the practice exam, the practice exam is like 99% analogous to how the actual exam is hosted and completed. It's just a shorter time period. So if you have any questions, it's not a bad idea to go back and do the practice exam so you get an idea of how it's going to be run.
By the way, if anyone is interested in the marks breakdown, it's actually available in that PDF, that sample exam PDF, the SolidWorks one, with the teal, I think it's teal part that Trevor was doing earlier. On page 5, there's a detailed breakdown of the questions and their points.
It's also available in the package that was provided to you from the professor.
Yeah, there's actually a whole sample exam zip on the SolidWorks website, but the link is dead. It leads nowhere, it just 404s. 403.
Sounds good.
So we're going to move towards Trevor's part modeling section in just a minute. If you guys want to just grab a glass of water or anything like that in the meantime, feel free to do so, and we'll get started in the next 2 to 3 minutes.
Yep.
All right. All right, guys, guys and gals and NB pals, as they say. It's been great so far, but it's pretty late where I am. I don't know if you can see the window behind me. So I'm going to have to drop out. Best of luck with the rest of the tutorial. Best of luck with your exams. Hope you all do well.
Awesome. Thanks for coming, Luca. That was an
Cheers.
awesome tutorial before.
Thanks.
All right. So it's just us now. What I wanted to do was a pretty complicated part, just so you can see kind of the process of how I think at the beginning of the parts before they start. And then if there's any potential problems, how I'd go back and kind of fix the problem. So I chose this one. It was actually from that package I recommended before, the one where you have to put your email in. And this is a bike pedal. So it goes on the bike. This would be attached to the bike, and then this is where your foot goes. There are 3 parts in this one, similar to the actual SolidWorks test. So I'll open them all up. Part A is similar to the one we looked at before, that teal color thing. You draw the sketch first, you do all the stuff, and then you find the mass. Actually, sorry, before you find the mass, you input, you have to input all this. Let me restart. You input all this information first. It's millimeters, grams, seconds, 2 decimal places. The origin is arbitrary. So that's your first step. Second step is drawing this all out, drawing the sketches, doing the features, whatever you need to do. Then you put in the materials, which I'm sure was covered in the lecture. And it gives you the actual density just in case it's wrong. And then it gives you a hint saying this part can be built using only 5 features. So what that means is in your feature tree in SolidWorks, the thing that's usually on the left when you have a part open, you only really need 5. If you have more, that's okay. But to be efficient and have less things there, you would have 5. So yeah, let's get started. I'll open up a new part. And the first thing I like to do is save it. That's because you can always hit Control S and quickly save it just in case. Materials first session, let's put it as bike pedal, and it's part A. And that's another thing. Every time you finish part A and you move on to part B, you want to save it as a different file, keeping everything from part A and moving on and changing what you need to do in a copy of that in part B, and then the same thing for part C. That was a tip that I got when I took the course before. I'm not sure if the professor went over that as well, but it's definitely a good thing to do. So say this is bike pedal A. And if you guys have any questions about that part, I will go over it when we move on to part B, just as you would during the test. Okay, so got the part ready to go. I will explain kind of what my thinking is behind this one. I haven't mastered this part yet. I've done it once just to make sure there's no absolute roadblocks that we can't figure out. But by no means do I know exactly do this, and then that. So we're gonna figure it out right now. So looking at it, it is symmetrical. If this is your pedal, this is where it's attached to the bike, like my arm. It's symmetrical in this plane, so right through the middle. And it's also symmetrical in this plane. So if I flip it, the plane like this. So looking at that, you don't need to draw everything twice. You can draw stuff once and either mirror it, or if it's already a feature, you can mirror the feature or extrude it on both sides. And I'll go over both of those once we get into it. So kind of looking at it, there's a lot of different views. I'm just gonna figure out what each view is. So section DD is here, straight to the middle, looking down the cross section of the middle. What we get is kind of a ledge. So there's a whole ledge around the bike pedal, just to hold your foot in, I guess. So I'll zoom in a bit so you can see. There's a 1 millimeter ledge there. So that's an important piece of information on this one, along with the thickness. The radius, I know from before, just because I did that one time, is 3 all around. So every radius is 3, every fillet is 3 millimeters. Oh, R3, just realized that. But yeah, so that's section D. This one is section EE, so across here. And the important information we get here is kind of the thickness of this core part, if you want to call that the core, and the diameter of the hole, where the bike pedal would attach to. So we went through section DD, section EE. From the side view, it's mostly just the slots the slots in the hole. We'll get to that when we need to. And the last thing is detail F. So it's this entire big circle around the top with the F here. That means this correlates with that, and you're looking at detail F. So this is your main sketch. This is where most of your information is, and it only shows you the top half. So you only really need to sketch the top half and then mirror it down, and you'll be able to get the rest of it. So yeah, let's start off in SolidWorks. Actually, I'll leave this up for, let's say 30 seconds. Take a screenshot of this page so you can kind of follow along. And if you don't do it now, I will probably be, that's weird. I will probably be, my bad. I'll pull this page up a few times just to explain certain things. We'll take a screenshot now, and we'll move on in 20 seconds. Oh, I thought they could hear you. Okay, never mind. Daniel's talking in the background. My bad. So yeah, it's going down. And there's the time. So hopefully you got a screenshot by now. If not, then I don't know, figure it out. So we'll start off with the bottom left detail F. Before that, first step is save. Second step is change the units. Millimeter, gram, second, mmsg. Decimal places is 2. I'm sure it was covered in the lectures. But if not, it's under document properties, dimensions, and your primary precision is what you need to do. So I already have it set to 2, which is good to go, and move on. Part origin is arbitrary. That's good for this one. We can start it wherever, but you do need to have a point on the origin or else it will be underdefined. And then the material type is plastics. We'll worry about that after, when we have to measure the weight, the mass. Okay, so now let's start on the sketch. I'm going to draw this on the top plane because that makes sense to me. Bike pedals are usually flat, so that's the way I normally look at it, and that's what I feel is right. You can start it anywhere you want. It's just preference. So on detail F, I'm going to go over. I'm just going to draw the whole outline of the top half. So I'll start off with that. And since I know, I'm going to rewind a little bit. Since I know it's symmetrical, I'm going to draw a line through the origin. And I know it's a construction line because it's not going to be used in the actual part. It's just there for reference or something else. And it's also infinite length. So it's just kind of something that is used for things of this nature. So it goes on forever. You can keep zooming out and it'll still be there. So anyways, that's basically my center line. Everything will be on the top of that and I'll mirror it down afterwards. So I'm holding the left mouse key, sorry, the right mouse key, and then that brings up this menu. You have your smart dimension, circle, rectangle, and line. You just kind of scroll over to it. That gives you that tool. So I'll start by going up, doing a tangent there. I don't want to have an auto snap. As you can see there, it might snap something, so I'm going to make it a bit wonky, just a little bit, so you can still tell what's going on. Have that down there, and then bring it straight down. So that's the basic outline. Then I'll add the relations, such as the tangent we need here. This is just holding control and clicking on the individual lines and arches. So that's the basic shape. Then I will add the radiuses, the radii. That's the right word. This one is 13. Sure. What can I do? Try that. Oh, SolidWorks is great. Ah, see, okay. I think it's a relation that I added that is making it messed up. Nope. So these could be problems you run into during the exam. I'm going to delete that and try it again. That is odd. Let's do a 3-point arc. 1, 2 on the endpoint.
You chose
and
3-point
3
arc.
out here. Yes, 3-point arc. And then let's add a radius to that. All right, so that worked. Let's make these all tangent. This one and that one. That's the wrong tangent way, so we'll delete that relation. Why do this?
You're getting that bubble formation because it's a 3-point arc. I think you have to do a tangent arc.
Okay, let's try tangent arc. Daniel's helping me out in the background. Thank you. So 1 and 2. Yes, that's working. Okay, cool. 13, and we're off to the races. So just kind of move these so they make a bit more sense. This radius is 22. And you can see this point is on the origin. It cannot move. That's good, that's important. If it could move, for example, like that, you would never have a fully defined sketch because this can move wherever it wants to go in this space. So make it coincident with the origin, make something coincident with the origin. That's super important to making your sketch fully defined. Okay, so I have the 2 radiuses. Now, what is stopping me from going on? We have 2 dimensions, A and this one, A and B. So those 2 will fully define the sketch. Before I put the dimension in, I'm going to make an equation. I believe it's under tools. I just find it easier to search it because it's easier. If you know what it's called, you'll always find it. Let's do A. I'm hitting tab to go over. A is 68, which evaluates to 68. B is 81. And C is 15. Nope. Maybe I have to change it after 15. Equals 15. All right, let's fix the name. Cool, so that's that. Now, in order to use the equation, I'm going to start off with B. So I'm going to put this up top because it's in a different drawing. You always have to put equal sign because if you just put in B in quotation marks, the quotation marks allow the software to know you're not just putting in something like a letter. It knows it's a variable and it will read what the variable is from your equation that you just made. So if you just put in B, it is right now, it's 81, it's supposed to be 81, but for the next parts, when you want to update what B is, it will no longer, it will stay as 81, it won't update along with it. So in order to have the updates, you always have to put equals, and then that makes it like a registered equation or whatever you want to call it. So equals B and the quotation marks. Capital B is different from lowercase b, so keep a note of that. Just hit OK. And you know it's an equation now because it has the sigma symbol. So that's super important. When you go on to the next part, like I said, if B is 52, for example, this will stay as 81 and everything will be wrong. So don't forget that equal sign. Okay, so that's B. We want to get A now. So I think this was covered in the lecture as well, but this is just giving me the dimension from my center line to the top. If you go down past it, it will give you, like, it knows you're going to mirror it afterwards, so it lets you have this option. So this entire thing is A. So equals, quotation mark, A, close quotation mark, and enter. And this globe here also tells you it's a global variable, meaning it's used throughout the whole part. So 68, that's right. We can start with the, oops. We can start with these smaller holes in the middle. So I'll start with this side here. Again, I'll just sketch it out similar to what it looks like. I don't want to snap it to this line. I just want to let it be. So up. Hovering over the point again to get the tangent. Going about there, there's a small little line in the middle. Hovering over again to bring it down. And that looks okay because I know it's going straight down. And then onto this line. Adding in the dimensions, this is a radius of 5. Radius of 5 millimeters. This one is 13 millimeters. And there's a space between, for the ledge, that's 3. We won't worry about that yet. So, kind of wondering, I put in all the dimensions for this part. I put in the 5, the 13, the 22. B over 4, I missed that one. Okay. So this space is B over 4. Again, equal sign, quotation mark, B, close quotation, and you can do normal functions in here. So divide sign, or the slash symbol is divide, and 4. So equals B over 4. 22.5, or 20.25, that sounds right. Okay, now that everything's in there, I'm kind of wondering why it's undefined or underdefined, right? I can still move it up and down. There's still some constraints, but they don't give me the dimension. This was a roadblock I actually ran into before, and good thing I did because it took a while to figure out. These two radius centers are the same point, so they have to be coincident. And the outer part is defined, and that leaves you a radius center. So when you draw your inner part, your cutout, that radius center is the same as the defined one. So now that is defined as well. I hope that makes sense. Throw a comment in the chat if it doesn't, and I'll explain it again. But I will make them coincident now. So it's this one here. I can't move it. See, it won't move. This one here I can move, right? So if I make that coincident or concentric, then now it's magically, not magically, but it makes sense. Now it's fully defined. Everything's black. Down at the bottom it says fully defined, so we're good to go. Okay, so we'll move on to the smaller, or the other hole. It's actually bigger. And let's figure out what we need to do here. So I'm thinking to do another symmetrical part, because these left and the right side are symmetrical along the center. So I'm going to draw a center line and put it somewhere close to where I think it should be. I'm not going to make it infinite length because it doesn't need to be, but it is there. So let's start drawing what this thing looks like. I'm going to leave it off on my other screen. From there, goes out and it's going to bend inwards. There's a small straight part. and then it goes out and it's bent inwards again. Right there. And all right, so it automatically adds the tangent mates, which you do need. I don't know why it messed me up at the very beginning. That was odd. But if that happens, you just gotta delete stuff and work around it. So let's throw in some dimensions between this center and the other center. It's a b over 3. Nope. Let's try that again. Here to here, going across the center line, it lets you dimension the full thing, equals b over 3. Okay. You add your radiuses. This one is 5. And this radius is 14. And what else do we have? The angle. So I can't really dimension across all the way with angles. So that's the one downside of using the symmetrical part, besides being really fast. So it's easy. This one is 20 degrees, half of that is 10. So I'm gonna put in 10 here. And we're still underdefined. So let's figure out what it is. We got something up there. So same thing as before, actually. The radius centers have to be coincident to each other. So that's that part defined because it's black. Now we have something that can move here. So looking at the sketch, the drawing, or the model, whatever you want to call it, I've put in everything from this one: the radius of 13, radius of 5, radius of 14, 20 degrees, b over 3, and everything else. So the part that's moving is up here. We have to look at another sketch or another view to get that number. So it's actually in section EE. So looking from the center here, the gap between the two holes is shown here as 10 millimeters. So again, that was a roadblock I ran into last time. It took me a little bit to figure out, but you just gotta start digging. So that's 10. We'll throw it in. 10 millimeters. And there we go, fully defined. So that's only half the sketch. Let's make it a full sketch. So I'm going to select all the entities. If you click and drag from the right to the left, so you're going to the left side, it shows a green box, and that will select everything that your box is touching. So I'll give an example. See how I'm touching this bottom horizontal center line? It will select that as well. See, it's nice and blue. I don't want to mirror that. I just want to mirror the parts that I'm hovering over. So if you click and drag towards the right side, it makes a blue box instead of a green box. And that will select only the things that are inside the box. They have to be fully enclosed in the box. As you can see, I was way out here touching this arch, this line here, and the bottom line. It just selects, actually that was fully enclosed, so I'm going to unselect it. But that's a very useful thing to know. It's not just randomly blue and green, they do mean something. So yeah, that's that. I want to mirror these entities that I just highlighted. I want to copy them instead of just mirroring them, because that would erase the originals, and mirror it about this line. I'm going to right click because the little icon is right beside my mouse at the check mark. And that's that. So that is pretty much everything for this sketch. I'm going to mirror the entire thing down now. Actually, sorry, one more thing. Got to make that little ledge. So this little ledge all the way around here. You can see this ledge From here, from section DED, right there, it just goes around the whole thing like a ledge. So to make that, I'm going to offset entities, use that feature. I want to offset it by 3 millimeters, which I got from here. I know it's 3 millimeters thick and 1 millimeter deep from down there. Reverse, we'll see how it goes. And I have to select the thing that I want to offset. So I clicked that line and went the wrong way. I'm going to reverse it. I can go around and start clicking all the lines, but that takes too long. So if you hit select chain, it will select the entire chain all the way around until it stops. Bidirectional if you want to do it both ways. So reversed and non-reversed. End caps just kind of closes off your part. So arcs is obviously arcs. They're tangent to the final ends. And then lines is just a straight line like the rectangle. I don't want end caps, so I'll leave it off. And that looks about right. We'll hit OK. If you don't hit add dimensions, it will draw the line without dimensions, so it's still undefined or underdefined, sorry. So I'm going to hit add dimensions because we want that 3 millimeters to show. Okay, now we're ready to mirror the entire thing. So I'm going to select everything here, mirror entities, let it load. Oh, my bad. It mirrored about the wrong line. So I'm going to undo mirror entities. It's not giving me the option on the side. Let's try exit sketch and go back in. And we'll click mirror entities first and then select what we want. We'll get rid of this center line. I actually should keep it. There, so now the option came up on the side. Mirror about this one. Copy is good because we want to copy it, not erase it. And hit OK. So there's your full part. You see it's fully defined, which is awesome. And now we can move on to the next part. So we've got this whole extrusion. We can add the nub next, where the bike pedal attaches to the bike. Oops. And that nub is where 10 millimeters of diameter for the whole thing and 5 millimeters for the diameter of the hole. Let's just make the diameter, the 10 millimeter diameter first, and then we can cut extrude everything all at once. Oh, my apologies. Before we do that, we have to extrude the whole thing to make a 3D object instead of just a sketch. So I can see that C is the thickness of the whole thing. And since I drew it on the on the top plane, I want to keep it symmetrical still. So I'm going to extrude half of it up and half of it down, just to keep it, like it kind of makes sense to do it that way. So extrude boss base. I'm going to extrude all of the areas except the holes because we don't want that. And we will do direction 1 and direction 2. So direction 1 is blind, yes, equals C. And I'm going to do over 2 because I want to have the top and the bottom. So C over 2, that will extrude it, whatever. C is 15, so extrude it 7.5 up. And then direction 2 equals C over 15, over 2, my bad. C over 2, and we should be good to go. So just to check, my bad. Oh, come on, computer. There should be a little thing up here where you can see your sketch planes, but it's not there right now. Actually, this works too. Just so you can see the top plane is still in the center. That's why I extruded half of it up and half of it down, just to keep it kind of making sense and for whatever reason. So we'll draw that little nub on the side first. Sketch that. The origin is actually conveniently right there, so that's good. If it wasn't, and you know it has to be in the center, you could draw a line across, select the center point, and that's the same. Or you can draw a big X, and then the center of that is there. Just if you draw anything, make sure it's construction lines. This is another way to switch it. So right now it's a proper line used for sketching. You can change it to construction geometry right there. So I'll do it that way. I'll select the center of that, just so the convenient origin, we're pretending it's not there. This was 10 millimeters. And we can extrude that out 8 millimeters. 8 millimeters I find here. Yeah. So features, extrude. Make that 8. And that should be good.
So there is a quick question in the chat.
Yep, what's up?
Can you please explain the 3 millimeter and the 1 millimeter offset?
Okay, so the 3 millimeter offset was the ledge around the side. I didn't actually do it yet. It's just in a sketch to be used in a minute. The 1 millimeter offset is kind of a ledge around the entire bike. So if your foot was on here, it's not just one flat surface. There's the ledge around the outside, which is up 1 millimeter high. So if you think about it, I was going to say rectangle, but it's not. What's that?
I was going to say you can kind of see it in section EE and section DD in the drawing here.
Yes, yes. So wait, Daniel, they can't hear you, right?
Oh, they can right now.
Oh, okay, good, good. So yeah, this ledge, it's 1 millimeter high, or the depth is 1 millimeter. So if you're looking at a bike pedal this way, you're looking down at it. The whole inner surface is 1 millimeter lower than the outside surface. It's hard to show in my hand, but I hope that makes sense. And in my sketch, I had the 3 millimeter offset here. I had it there, but I didn't actually use it yet. So I will use it in a second, and I will show you how right now. So I'm going to rewind a little bit, go back into the sketch. And looking at that photo, where's the thickness part? Section DD. So the whole thickness is C, which is what I extruded it to, but I actually wanted to extrude the entire thing C minus 1 to get the entire inner surface the same level, and then extrude the outer part 1 millimeter more to give it the proper features. So let me do that right now. The regions were not this one. So actually, thank you very much for that question, because I would have stumbled upon it before or afterwards. So I'll extrude that part, C over 2 minus 1. And then this one, C over 2 minus 1. And see how it keeps the equation? That's because the equal sign is there. If I took that out, it would calculate it and just put the number in, which is not what we need. We need to have C be updated. So I'm going to copy and paste that here. C over 2 minus 1, hit OK. And that gives us this. And I'm going to extrude another one. Or can I make it in the same sketch? I don't think so. Yep, so it would be another feature. So extrude. I'm going to find the sketch that I just drew on. here. When you click on it, it kind of makes it appear, and then you can select what you want. So I want that part. I'm going to make it, this one was just C over 2. So equals C over 2. And then the same thing, direction 2 equals C over 2. And then that will give us that 1 millimeter lip around the whole side. Or ledge, whatever you want to call it, lip or ledge. I hope that makes sense. If you're still confused about it, throw it in the comments and we'll go over it again. Okay, so that's the base of the bike, or the foundation, whatever you want to call it. What it generally looks like. Now we have to add in the smaller features. So slide this over. On this view, I'm going to work on that now. So it's the 2 slots, top and bottom, and then the center hole. Looking at it now, it's symmetrical because they give us the dimensions on one side. So from the center of this to the center of that, it's 14, and then this center to that center is 10. And it would be the exact same on the bottom. So I'm going to use the mirror feature again. We'll sketch on this plane. I will draw a line across the whole thing. Convenient origin. Thank you. Before I draw the line, for construction and infinite length, you don't need to use infinite length on this one. It's just good to, you could draw it halfway across or across the whole thing, whatever you want. It's just good for situations like this. And let's draw, which one first? Let's draw the slot on the right side. So I know this slot has centers of 10 millimeters. This one's also going to be a construction line. Reason being, you'll see. I'll do circles for now. The circles have a diameter of 5. Oh. That's a line. So what I can actually do is make them equal. So they have the same radius. Draw the line on the top to connect them. So that's all good. And I will then use the snipping tool, or what's it called? Trim tool, trim entities to trim the bottom part and inside here once it's done, once the dimensions are in. Actually, let's do it now. So trim, you click that and you just hover over everything you want trimmed. And it will cut whatever's between the section you just trimmed, or the section you just run through, and the 2 points that are in any sort connecting it. So see for that one, it'd be this point, nothing, 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 in this point. So we'll trim everything between those 2. So that's good. Let's add the dimension in from here to here. That is 5. The dimension, what's missing? From the center to the center of the slot, that will be 10. And the center of the slot on one side to the center of the slot on the other side will be 14. And this circle here has a diameter of 10. And just to make it right, we can, oh, sorry, it's 5. 5. It's trim entity, so it makes sense. Didn't click it. There we go. Okay. One little thing. My computer says mod diam. I guess I don't know what mod means, but diam is obviously diameter. Yours should have a circle with a line through it. I guess SolidWorks just doesn't read the symbols on my computer, so it leaves like the code behind it instead. You shouldn't have that, and don't worry about it, but that's why it's there. So I'm going to draw another construction line up here, just kind of arbitrary. Make it a construction line. I'm going to connect it here so it's defined, and then trim the other quarter of the circle. So now I can mirror this twice and everything will be there. And again, we're fully defined. Check that often. So I want to mirror this one and then everything that I hover over, not including this. And I want to mirror it about this line. Hit OK. Do the same thing again. Mirroring about this line. Mirror entities to mirror everything there. And mirror about this line. There we go. So as we can see in the drawing, everything that we just drew is cut through all the way in both directions. When I say both directions, I mean we made this knob here before. If you just extrude it one way, which I will do right now, it won't cut. It won't cut towards the screen, let's say, out of the screen. It will only cut into the screen because you're cutting in one way. So I want to hit direction 1 through all, both. So you go both directions and it will cut through everything, all, and that's what you need in this case. So hit OK, looks good. And I'm noticing here, there's some error. So I'm going to try rebuilding. It might go away. And it tells me what's wrong. So something in sketch 2. Let's check it out. Okay, so this line we drew before to find the middle point no longer exists because what it was coincident with is no longer there, because that would be that 1 millimeter gap that we talked about before. So I'm just going to delete this line. And this is still defined because it's on the origin, but I'm going to delete that because the origin might not always be there. It was just good placing. So I'm going to convert this box, convert entities. So we can now draw on it. And I'm going to make this box construction geometry. And we'll put a line through the center and make the center of the circle with the midpoint of that line. Make them coincident. Midpoint. Think about this for a sec. So select midpoint, select the circle point, make coincident. There we go. That was odd. I guess I just did it a different way. But it's if that happens, just try it again. Delete something that's causing the error and try it again. Okay, so that's good. Exit sketch. Should rebuild properly. It's not. What's the problem? Could not find a facer plane. Okay, that we can do. That we can fix. edit sketch plane, this one here. So that 1 millimeter ledge is no longer there. It was the wrong order of operations because I went back and changed it. And now the feature is below it. So we have, it's the order of features that's making the error. So we have this extrude of the center. Then we did the extrude of the little knob. And then after we did the extrude of the whole thing. So when I drew the knob initially, it was out there. And then when I did it again, it's just on the inner part. So this is actually a problem. And I'm going to see if I can fix it by putting that up. And hopefully it goes. I'll change the sketch plane again to here. And sort through the errors. So that looks okay. Again, that was the same thing as before. So let's figure it out. I'm going to delete all of the lines. It's being funky now. There we go. Do this one more time. Convert entities, make them all construction geometry, not the circle. Draw the line across. Make a construction. Select the circle, select the midpoint of this line. I'm going to do midpoint first because it seemed to work well. So select midpoint, select the circle, and make them coincident. And that should be good now. Awesome. Okay, so we got through that one. Just to check, or just to recap before, what happened is this part, which does not include the ledge, was extruded first, and then I drew this 8mm extrusion circle, the nub that goes onto the bike, and then I did this ledger on the outside. So it was making this nub onto the inner part, which is not right because it would be much less than 8mm. So just to check, I have my hotkey set up for M to be measure. We'll check that, and the normal distance is 8mm, which is correct, thankfully. So we can move on there. Everything is extruded through here. And that looks like about everything that I can see besides the fillets. That's there. I'm just checking through, remembering if I did put these dimensions. We did the 10, did the 5, the 15 is C, 10mm for there, 14 there, 8 there, 1mm gap. That was all good. The 10 or 5mm hole we put in, and the 10mm kind of core support thing between the two holes we put in. So other than that, or that's everything for there, we'll just add the fillet. So they're all three. I know I checked that before on all the inner circles here. So we'll put that in. So to do that, I'm sure you guys use the fillet tool. It's the best thing ever. You select the edge. It doesn't show a preview, mainly because 10mm won't work. It would be too big, so let's make it 3. I want to have everything on a single feature, so I'm not going to do the top in one, hit OK, and then do the bottom in another. I'm just going to do it all in one because they're all 3mm. It's kind of messy right now, but you can kind of decipher that the bottom, the top, the bottom, the top, and the bottom, the top for those 3 holes. And we'll hit OK. And that should be everything. If we want to do a section view of EE, we can kind of just throw that in. So EE is looking this way. I'm going to do a section from this face, bring it in somewhere about there, and just kind of look at it. So Lucas said he always likes to measure things afterwards, which is great. So let's do that. From section view EE, we have the radiuses, which we know we just put in, which are good. We can do this 10 millimeter and the 5 millimeter hole. So this should be 10. Why is it not 10? Did I click somewhere else? From face to face. There we go, 10. I think I clicked on a line somewhere else. Yeah, maybe this line out here. But face to face is 10, which is good. That's really all from section EE. The 5 is good because that was from a sketch. D, we can check this small. The lip we can actually check in this one too, so we don't have to change the section view. So this lip is 1 millimeter. You can see the length, 1 millimeter, perfect. We could also do from this face to this face, same thing. Normal distance, the purple one, 1 millimeter, awesome. So that's it for this part A. What we have to do now is add the material, check the density, and find the mass. So let's do that. Material is found here. In the feature tree, you right-click it and then edit material. The plastic is called PE high density with a density of 952 kilograms per meters cubed. So we go to plastics. PE high density with a density of 952 kilograms per meters cubed. So we'll hit apply, throw that material on, hit close. It did change color a little bit, so I know it did change material. That's kind of like a double check. So yeah, we'll exit that and let's find the mass. So it's under evaluate, mass properties. The mass is 31.20 grams. And in here, I've saved it in the thing and it's 32.4 grams. So there's a mistake somewhere. In reality, since we know the number and it's multiple choice, actually, Daniel,
Yes.
Something like this would likely be multiple choice, right? It depends, I guess.
For something like this, it would either be multiple choice or yes, it would be multiple choice.
Okay.
And you're allowed to be within 1% of an option that is given to you.
Okay, so let's see if it's within that 1%. It should be exact, but
That's not how that works.
So is that not how it works?
No. So it's 1% of 32, which is like
0.01,
0.3 or something like that.
32.4.
Divided
So
by 100.
okay, yeah. Yes, I see. I see. So
I think I know what the issue is here.
324. What's that?
I think I know what the issue is here. You forgot to do something. If anyone in the chat, what is the weight supposed to be? 32.7?
0.4. It's saved in, if you took a screenshot, it's up in the file number or the file name.
Yeah, so the mass is supposed to be 32.4, but you're weighing in at 31.7, right?
Yes, I think so. 31.2.
Right. So there's something you're missing. You can use the mass to tell you that maybe you missed a feature, maybe you cut too much away. This is the time where you should be going back to your drawings and double checking every single detail that you can think of and making sure that all of your cuts and your extrudes are right.
So if I'm underweight, there's something missing. Whoa. Orange. Let's see. This hole looks a little big. The inside should be 5, the outside should
So
be
there's
10.
a comment in the chat that says the oval hole is 14 millimeters, not 10 millimeters as you have done, or as is on the document.
Okay,
So
that's a
maybe
good one.
double check that.
So we have,
the oval cut out the slot that you did there. I think the dimension is supposed to be 10 millimeters instead of 14.
So they're switched then. Ah, yes,
Yes.
thank you.
That's a good catch.
Awesome catch. So even it's moved over too far because it's, or no, wait. It's supposed to be 14 over and 10
Yes.
distance. So it's moved over too far, and
You've cut away
since it
too
is,
much material.
yeah, well, besides the actual like slot is way too big, it's also a little bit of material difference on here. I don't know if it's hard to tell, but it's starting on the curve, so you would be missing a little bit of material there too. But the main problem is definitely this part. Thank you very much, whoever that was.
That would be Mohammed.
Thank you, Mohammed. Okay, so we did that. And another thing too about mirroring is because it's mirrored, it updates this side as well. So you don't have to do it twice. We can check that with the measure tool from this point to this point is, where are we? Is 10 millimeters instead of 14. So this was 14.2 before, but since we mirrored it, everything kind of syncs up, and now it's fixed as well. So exit sketch, it will rebuild. It definitely looks smaller. And let's check our mass again. 32.4, awesome. The right answer is 32.4, so we're good to go. Just 1 second, my throat's gonna dry. All right, so we've done part A. Now we'll move on to part B. And what I was mentioning at the beginning is that when you move on to a new part, you do want to save your first part just in case for whatever reason. If you totally mess up part B, you can always go back and save a new part B from the original part A instead of messing up the original thing. That's one reason among others, which I don't know of, but it's just good practice. So in order to do that, save as bike pedal B. It's in the same folder, so that's good. Save that, and it automatically updates you. So you should be working on part B now instead of A. So A saved, it's in the back burner. Now you're working on B. So for part B, what we're doing is adding in these little pegs. So this is more support for your feet, more grip. I see that they are all 2 by 2 millimeters, and there's 28 of them, so we can count half, count the bottom half. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 times 2 is 28. So if there's 14 on half, 28 in the whole thing, we know they're all 2 millimeters. Let's say there was 12 here, or whatever. Yeah, there'd be 12 on the bottom. The extra 4 would be found in the middle. If this had 24, something would be different. So since they're all covered, there's all 28. There's 28 there, and the detail H says that there's 28 2x2 squares. That means they're all covered. And I'm not going to draw each square individually. I'm going to use the linear pattern tool to make life easier. And remember that little 1 millimeter ledge that we talked about before on the whole outside? These 4 in the middle are 1 millimeter down. So if you look at the photo, you can tell they're a little bit thicker than these ones. So if you looked at it from the, let's call it the front view on this side, looking at it that way, you would see that all of these divots are the same height. So these are 2 millimeters that account for the 1 millimeter gap here. And then those are all 1 millimeter and so on. And you can also tell from, actually, this was the exact view I was trying to explain. The middle parts here, they're all the same height. So yeah, let's draw these middle things. I did think of a smart way to do it. It's just math. I wouldn't recommend doing this, but it's just something you can think of as you're going along. If these are all 2x2 millimeters, 1 millimeter high, and there's 24 on the top, 14 on the top, 14 on the bottom, you could actually find the volume multiplied by the density to find the added weight, since nothing else changed. But thinking now a little bit more, you can't, because it would change these global variables. Again, I don't recommend doing it. Don't do that, because it might screw you up in the future. But it's just another way to think of doing the problem. Okay, so let's start it. I'm going to orient my part so it makes sense. Looking at the top view. For anyone that doesn't know how that works, I just hit space and it comes up with this cube you can move around. Or it brings up this button and you can choose top, front, bottom, right and left, and so on, and back. But I want to do the top view, so it's there. So the first one I draw is going to be the very bottom right one, because it has all the dimensions. And I know it's 13 millimeters from this back face to there. So let's draw it on this face. Sketch. Use that one. The rectangle. Draw a rough square. I want to make all the sides of equal length. Of 2 millimeters. Where it's located is 0.5 millimeters from the bottom. And since this thing is 3, the entire gap is 3. The part we're drawing is 2. There's an extra space of 1. And since you have a top and a bottom, 1 divided by 2 is 0.5. So that's where they get that. So we'll do 1 here, make it 0.5. And I'm going to put it off to this side because in the sketch, it's off to the right. Oh, sorry, it's off to the left. Just to kind of keep things where they were in the sketch so you can double check. So like that problem that Mohammed brought up before, or that he found before, if I was going through it, I could see that like the 10 was up here and the 14's here, versus if they were down at the bottom or like switched somehow. It's just, it's for ease of clarity, or easier to see. So let's do that. This gap is 13. And the gap between each of them is also 2 millimeters. So I'm going to, where are we? Linear sketch pattern. You also have the option of circular sketch pattern, but right now we need linear. Direction along this way. How many we want? We have 14, so we want 12. 12 on the bottom. To make an X spacing is a big one. Otherwise, it will place them all where you say they need to be, which is 2 millimeters. So it will place them all at 2 millimeters, but it won't dimension it. So you can still move it and it will change. So if you click dimension X spacing, that will add the dimension and you won't be able to change it. Direction 2 we don't need because there's nothing going backwards. If you did, you would change this from 1 to something else, like another number. But we need 1 because if you have 0, it doesn't make sense. And entities to pattern is the square. And let me correct myself, the dimension is not actually 2. It would be 4 because the gap is 2 millimeters and the part is 2 millimeters. So from edge to edge, the difference would be 4 millimeters. So that's that. It looks like it ends right where the curve starts. We'll just do a visual check. It ends just before the curve starts, so that looks off. Get 12. So we'll check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The 2 millimeter gap. Should be right. I guess the visual is off, but yeah. So I'm going to draw the top ones as well. The ones more in the center. Sorry. The ones in the center. So we can extrude it up to have the parallelness and then extrude it down. All of them can go down because these ones would just be going into more material, which doesn't add any more material. So let's draw another square. Out here, make it all equal. Dimension one side of 2. And it's located. So I'm going to use that handy origin. Put this all the way across so it's not underdefined. And make this construction. And that's actually really important for later too, because we're going to have to flip everything on the top. So from the top face to the line, from the top face to the bottom face of the other one would be 14. So that line, remember, it kind of acts as a mirror. Let's put that as 14. And how far from the right side? That would be 7. So that's the location of it. We'll do the other one here. And I can see that they're both 14. So I'm going to make this face and this face horizontal from each other. That's not the right one, sorry. Collinear. So that this actually draws a small dotted line to tell you that they're collinear. So if this 14 dimension changed to 12, this would go up and then this would go up as well. And the horizontal location of these ones are 4 millimeters from the edge, not the tangent edge or the edge of the fillet, but the edge of the actual hole. So I can actually do it to that line there. And that's 4. We can now mirror everything. Entities to mirror. Select all those. I don't want this center line. Copy it and mirror it about there. Hit OK. extrude it all up 1 millimeter. Where are we? 1 millimeter, and we'll extrude it down up to surface because we want to extrude it up to the surface. The second direction is just to get from the plane we drew on, which was above this here. You can see that's the plane, the blue part. So the first one was extruding it up, and the second was extruding it just for these 4 in the middle down into there. These also extruded down, but there's already material there, so it's not adding any more material. Okay, so the next thing we want to have this on the opposite side because we can see the squares are on both sides. So let's do that. It's a mirror feature. I'm going to mirror these about the top plane. And let's see if that works. Looks good. So what that feature did, it just took everything that we extruded and mirrored around or about the center plane. So remember at the beginning how I did 2 extrudes, one up, one down? This one here. So the center is where it was sketched and then extruded one way, direction 1, and extruded the other way, direction 2. That's because everything's symmetrical and it keeps it all aligned. It's also a good habit because if you have to change something, you can change it on one side and it will sync up and change the other side as well when you use the mirror features. So anyways, that's the updates for this drawing. We've added all the nubs. All the dimensions are there. They're 1 millimeter, those are 14. The only thing we have to do is change the global variables. So keep this off to the side. All the equations are here. Just right click on it, manage equations, and you'll be able to change them. These are all equations that were kind of developed as we were going. So like remember, we did b over 4 for one of them, b over 3, and then c over 2 minus 1. It saves all those in the equation. So all I want to change is a, b, and c. So a is 72. What? Oh, that's down here. That's odd. B is 83.5. And C is 16.5. So 72, 83.5, and 16.5. Okay. When you hit OK, it rebuilds the document, so it updates all those dimensions. All right, that looks good. So we've done everything, kind of double checked it before. Let's check the mass on this one. 40.12 grams. The answer is 40.12 grams. So this one's good. You'd put that in the test and that would be right. Part C is fairly easy. It's just adding fillets to everything and updating that. So I'll do it quickly and then we'll jump to the question period where if any questions about what we went over or anything else, or you want to kind of go through another model quickly, we can do that. So let's do part C and then we'll get to that part. So again, I'm going to save as a new file, just in case you have to go back to part B for whatever reason. part C. Let it save, and then just check that the name updates. Good. Wait, Daniel, are you still there? Okay, my two screens just crashed, so.
Okay.
Just checking. Okay, we're still good. Okay, so part C is just adding fillets. What's up?
At least I'm not seeing anything change on my end. Oh, there we go. Okay, we're good.
There? Okay. Yeah, I think it was the photos that crashed. Because I can't open photos now. Great. There we go. Okay. So here's part C. Again, it's just updating the variables and adding fillets to the inner parts of the cutouts. So let's start with the variables. That's an easy thing to do. A is 74. I'm just hitting enter to go through the next ones. B is 87 and C is 18. So just check that it evaluates too, because this is what actually goes into your equation. So if you ever needed to, I'm going to leave that one how it was. I'm going to make a new one. I'm going to call it F. And I'm going to use a variable from before. So I'm going to call it A over 2. And then now F will be A over 2, which is 74 divided by 2, which would be 37. Yeah, so we got 37. And then if you updated A, F would update as well because it includes A. It's just something to keep a note of. You might find it useful during the exam. If you don't, then at least you know. But let's delete that one. Or just leave it there because it doesn't want to go away. There we go, delete equation. All right, so 74, 87, 18. What's the problem? I just hit OK. I'll go back into the equations after and just check. 74, 87, 18. Okay. I think it was because I was messing around with the F before, but that's okay. So fillets. I have to add fillets. Fillet, it will be all the interfaces. So right in there. I'll do everything I can see first before moving it. Right in there. Right in there. So I'm selecting an interface that does both sides. If this one I selected the interface, it would also do both sides, which we do want, which is good. If you don't want to do both sides, you can select an edge, and then that will just do the inner part, whatever chain you selected. But we want both sides, so I'm going to do the face, which goes through both ways. I hope that makes sense. Let me know if you have any questions.
There doesn't seem to be any questions as of right now, at least.
Okay, perfect. So we've got most of them. There is one more two up in here, so we got a fillet there and a fillet there with all a radius of 1 millimeter. So let's do those two. Add the radius of 1 millimeter here too. then click OK. So that should be the new part. Everything looks to be filleted, right? Or filleted. So I think that's it. We updated the variables and added the fillets. So let's check the mass. 47.67. And what we have for the answer is, right, 57.67. I believe this was a mistake because I did it. I think I had someone else check it and they got the exact same thing. So it should be 47.67. I do apologize for that, but this should be the right part. We can double check the variables because that's the only thing that would add 10 grams because there's not really much else that could add that much weight. So 74, 87, and 18. 74, 87, and 18. Yeah, so that's a mistake in this book, or this question, this answer. But I'm just guessing it's a mistake because it's 57 instead of 47, and the decimal points are the exact same, and there's a 1 in 100 chance of that happening. So let's assume that's what it is. Okay, so that's everything. I guess we'll do some questions, and then after that, we can go to sleep. No, I'm kidding. Spend the rest of your night doing
7 p.m.
practice, not sleep.
Suddenly we're all grandmas.
Tired, okay. I can go over anything that we went over today, any part of this question. I can explain mates a little bit more. If there's any specific questions on that. Saving your parts, using the mirror feature, whatever else. Convert entities, offset entities. What else is very useful? Linear pattern, circular pattern. These ones are not used very much, if at all, for stuff like this.
Yeah, I don't think those are used on the CSWA at least.
Yeah, these are like, quite complicated. Like a table-driven pattern, that's not that's too much. But yeah, toss the questions in.
There's no questions currently in the chat. If you guys have any questions, feel free. This is kind of our like wrap up period. If there's any general questions about the CSWA exam again, more than happy to answer those. General SolidWorks questions, if you ran into a problem with a specific feature or you're not sure how a specific feature may work, feel free to ask us. So long as it's relevant to the exam, we will do our best to answer the question.
Daniel, was there anything that you saw that might be confusing?
Was there anything that you said that might have been confusing?
Yeah, like is there something that you saw that you think would be good to know?
I'm sorry, you're muffling up a lot right now. Can you say that again?
Is there something that you saw just that might be confusing or should have a recap on?
No, I don't think so.
Okay.
So there is a question. If we are off by less than 1%, what should we do then? So that's where either of us can really answer this question, but that's where that 1% allowance comes in on the exam. So long as you are within 1% of the exam paper. So let's say they give you a weight of 32.5 pounds. So long as you are within a 1% 1% of that number, so you would take 32.5 divided by 100, that would give you what, 0.325? So you have an allowance of that much to be within, and you will still get full marks on your question. Any more or any deviation more than that, and you will start to lose marks.
Would you lose marks or just like it's completely wrong? Like they don't take off, they don't give partial marks, right?
I'm not 100% sure on that. The professor might have discussed that during lectures, but you will be able to see the scoring breakdown on the practice exams of how you were penalized per question
Okay.
if you are more than 1% off or anything like that. I will say this from personal experience. It's very rare that you are just within 1%. You either get the number or you really don't. So I wouldn't bank on being within 1%. Obviously check, but don't count on it because there's very rarely a case where you've made such a minimal error. Someone else is commenting in the chat that there are no partial marks. Again, I
Okay.
can't confirm. I don't remember exactly.
Okay. Good to know. So you have to be dead on or nothing.
Yeah. If you guys have any questions about drawings or drafting that might be on the exam, I know it's a pretty small part of the exam, but if you have any questions about those, we're more than happy to answer those questions as well. Or if there's any questions about anything else that was covered today.
I guess I'd go over a little bit of what I messed up on before, just so we know for sure. So near the beginning, we ran into the error of drawing this whole thing, extruding it in two directions, up and down, of just the center part, not the ledge. So the ledge was not involved yet. And then we drew the 8mm nub, stuck it in a little bit, or put it onto the face here before the ledge was there. And then we added the ledge afterwards. So the face that this nub was drawn on no longer exists. So that's why it caused an error. To fix that, I put the ledge on first in up here in the feature tree. So yeah, it was this ledge, if I can highlight it, or the inner part. Okay, it doesn't want to highlight, but it's just the inner part and then the outer part and then this face. Before it was reversed. So it was the inner part, then the nub, and then the outer part, and then this nub was drawn on the line right in there. Anyways, this small line in here. And then the outer part was added and the line no longer existed. So that's what the problem was there. What else was there? I think that was it for this one. Oh, at the beginning, I don't know, some messed up part with being tangent and having that radius of 13 over here. That one I actually can't explain because I have no idea what's going on. But just delete it and try it again and it should be good. If something else keeps happening, try a different tool. So I start off with the line tool, drawing a tangent line here and then continuing it on. And then for some reason it kind of snapped to something. So I deleted that, and then Daniel suggested using the tangent arc, which which worked. So it was tangent from this point and then just touching that point, and then you mate the two, or what's it called, mating? You add a relation between the two of the tangent relation, so then it works there. And I think, what else was the problem? Oh yeah, that Muhammad pointed out, there was a wrong dimension. So that one is, I don't know, it's kind of sneaky. I guess because they look the same, 14 and 10.
Yeah, it's also just kind of being careful when you read your drawings for your parts. Like as you're doing it, like when you're doing your sketch, do the sketch how you read it, then double check before you cut or do anything else or before you mirror it. Like make sure you've developed a process of just triple, quadruple checking yourself to make sure that you're not making a really simple, easy mistake because um, during the exam you will be stressed and you will be uh, confused. You're going to double check stuff, triple check stuff, and you're still going to miss really easy mistakes. So just make sure you build that in as you're doing your problems, as you're doing your practice, that you're checking every part of your sketch as you do them, just to make sure that you're not making that mistake over and over again, or that you're not misreading your diagrams in any way.
Mhm.
There is a question regarding the theory portion of the exam and how one should prepare for that. Um, that's a good question. From what I
What's
remember,
what
sorry,
was it about the theory portion?
I think it's mostly if you scroll up to that section where it kind of outlines the different parts of the exam.
Yep.
Here, I think it's mostly the drafting competencies, right?
Okay.
Because basic part creation is a model, intermediate part creation is a model, advanced is a model, then you have an assembly. Those are really your drafting and uh, general problem solving questions. I wouldn't put too much weight onto these. Really, the best way to get an idea of what you're doing with those is to take the practice exam or find a YouTube tutorial that goes over the practice exam and they'll show you or do the questions that are here for practice, right? It'll show you like, how do I get this type of a view? And it's just your innate knowledge of the different SolidWorks tools and how they work and what you want. There's no real easy way to say how to study for these questions. It's just you've got to do problems. As you do them, as you make drawings for them, you'll kind of understand what tools for your drawings will do what and how those end up interacting with what you want. And understanding the nomenclature of certain terms as well will help a great deal. At least for that's what my experience is.
That that's very good advice. I'm just trying to figure out that first one now. I'm pretty sure, like for example, this one here. I'm pretty sure this is a crop view, but if you can want to double check, you can go in SolidWorks and add in your some part, and then go see what a crop view is.
You can maybe search for it. Oh, there it is.
Crop view. So please sketch a closed sketch profile and the drawing to get a crop view. So we'll sketch a weird looking line just so we can get a good idea. So it's not just a rectangle. And then add a crop view.
I think you have to be in an isometric view, maybe.
Possibly. Or does it tell you what a crop view is? Crops an existing view to show only a portion of the view.
So it'll crop everything out of side of what you selected, is the way
Yes,
I
so
understand that.
yeah, that's what I think it is too. So make it isometric. Maybe because it's underdefined, I don't know. But let's try again.
Are you sure it
Please
doesn't give
select
you
the
the option,
sketch.
try sketching something right now? Like, no, don't use the like draw tool or anything, like the line tool. Just select the crop tool and then like draw a circle, basically.
Okay. How to get rid of these sketches? I don't know why I'm having so much trouble right now.
The struggle.
I swear, if this was not on being recorded, it'd be fine. Maybe not, but Murphy's Law never fails. So crop view, and then you said draw a circle, right?
No, don't open up a tool. Don't open up another tool or anything. Just like make a circle or select something. Yeah.
No, I think you have to. Because it says please sketch a closed profile.
Oh, okay, I don't know.
So you have to sketch something. I don't know, that is something else. But just based on the explanation of what a crop view is, this looks like the leg of a chair or something. And it probably extends past where it's cut off on the right side where that 90-degree angle is. So I would take that as a crop view. You have a view and then you have this isometric view and then you crop out part of it. Where was it? So like here you have this isometric view and then you're cropping out this part. I know section view is seeing inside of the thing. So you're kind of like taking a section of it, cutting it and looking down or however way. Projected view is like, if you have this, you would look at it from a different angle.
Yeah, or
an
even a
isometric
different
view.
scale, I think, for a projected view.
Yeah.
Oh, no, you look at it from a different angle. Yeah, you're right.
You could do scale too, I'm pretty sure.
Yeah.
You just say like projected scale 1 to 2 or something. And then isometric view is definitely not this. This is an isometric view.
Yes.
That is not. So by process of elimination, I would select crop. But yeah, I don't really know what else you would need to study for this part. You could figure this stuff out on the spot when you're doing it, or just go over all the tools.
Yeah.
And just understanding what each one kind of does and what it's called. But we'll try this one too, just so to go over it. So to create drawing view B, is necessary to sketch a spline as shown on drawing view A and insert which Solidworks type of view. Which
So
Solidworks view type?
Scroll up, the part is above. There, yeah.
Oh, this one.
Yep.
So to create B, you have to sketch a spline, which is the weird not square, rounded square. And select which type of view. So there's obviously, or what you can see is there's a hatch mark here. That means that you're cutting through material of some sort. So that's one thing to keep in note of.
That is not through the whole material.
Yes.
That's the key point there.
So I would, there's not a detail view. We know what detail view is. It's when it just highlights a single part and makes it bigger, like it would take off this corner and explode it, so it's nice and big. A line section, that doesn't sound right. Is that even a thing in a line section? Probably. I don't think they would joke around like this.
Maybe search for it.
Yeah.
I think it's a certain type of section view where your section is aligned off a point of reference from your drawing or from your part. That's
okay.
how I would understand that.
Okay, that makes sense.
If you, what are the other options there for the?
For section. Oh, on the sorry.
Yeah, sorry.
Detail. So it's not that detail.
Broken out section. And section. A broken out section.
That one makes the most sense to me because it's kind of broken out. Like it's not a full section view would be a cross section of the entire thing.
Right.
Broken out section, which I think would be this, is a just a part of the section view. So we can try in SolidWorks, search up broken out section. Broken out section. So it's crossed off for whatever reason. But you can read what it says, which is adds a broken out section to an existing view, exposing inner details of the model. So
Can you say that
that
again?
makes where'd it go?
As a broken out section into an existing view, exposing the inner details of the model. Yeah. So it would be a
So
broken
that
out section.
one, yes, and we can probably try it. Oh, there you draw a spline here. Yeah, this one's odd because it's
You have
not.
to choose the depth.
Yeah, it's an isometric, so it's going to look really weird. But let's call it that.
You have to choose the direction.
Oh, damn. Depth. Let's go this way. Yeah, I don't know what I'm doing for this one here.
It might not be deep enough or something, but yeah, it would be a broken out section in that case. Really, it's just playing around with the drawing tools. And if there's one that you don't recognize in the practice, take the time to research it and double check what it does and see how it interacts. Another great way would be to go over some YouTube tutorials that specifically mention what those are. I know it's kind of a afterthought because it's worth so few marks comparatively. And that's also something to remember is that um, you don't have to get 100. Obviously, do as well as you can, but if you know you can do the parts section and you can do the assemblies section, I believe that gets you the marks to pass. But also allocate your time accordingly as you need.
And definitely don't get hung up on something like this.
I've made that mistake as well, getting hung up on something for like an hour in the exam, and then you're not able to finish.
Hmm. All right.
I think we should
a
wrap
couple
it up
more
here.
minutes. Okay.
If there's no other last minute questions, we will call it a night. Just as a reminder for everyone, there will be another tutorial session on the 18th from 6 to 8 p.m. I'm just double checking that right now. Yep, the 18th from 6 to 8 p.m. With Jacob, who is R3 Mechanical Mentor, who's completed his SolidWorks professional licensing exam.
And he's got some pretty cool parts to go over, so
Yeah.
highly recommend to visit to watch that one as well.
All right,
Cool.
everybody.
So yeah, I hope that was useful. Try to do the best I can and go over as much as possible. So hopefully it did something. And yeah.
I would say the same. Good luck. Make sure you study lots. Do not take the exam lightly. It's a tough exam, even though you have 3 hours and you don't really need the 3 hours. If you end up finding yourself stuck, you're going to need those 3 hours. So make sure you've done as much as you can to prepare as well as you can.
And if you feel comfortable, I would say don't stress. Just keep practicing and just take your time. Like, not take your time, like sit there forever, but don't rush it because some mistake like the 14 and 10 millimeter thing before that could be due to rushing. So just do it thoroughly and keep focused.
All right, everybody. I think we're going to end the stream here. Thank you all for sticking around. Thank you for your questions.
Questions are good.
And with that, anything else you want to say, Trevor, I guess, before I just end the stream?
Other than good luck and all the best, no.
All right. Have a good night, everyone.
All right, take care.
Bye.